Hello everybody and welcome to my bi-weekly devlog about OMAPELI. This time you will see how I created well-performing leaves for the trees in OMAPELI, and I also briefly show some lesser changes that I made. However, first, to those who may not know, OMAPELI is my 3D action RPG game project setting in a medieval fantasy world. You will be able to fight with magic, melee and ranged weapons, do quests, craft and generally fool around. If you would like to be updated on the game's progress, please feel free to follow the game on itch.io, Twitter and here on YouTube. But without further ado, let's get down to the business by first looking at how to create tree leaves parametrically. In OMAPELI, from the beginning I wanted to have all the models parametric. By this I mean that instead of using Blender or another 3D modeling software, I have been creating mostly Python code to create all my 3D models during the game's runtime. This is because if I design the code smartly enough, I can simply change the input parameters to produce varied or completely new 3D models for the game. Let's examine the trees of OMAPELI for example. As you can see here, by merely changing the numbers, I can create various different types of trees in an instant. This makes it feasible for a solo dev like me to create a huge tree variety without spending too much time in 3D modeling. So I started to make leaves by first coding a parametric model for a leaf following the Panda3D's manual for procedural model generation. It always takes me some trial and error to get the things right, but here you can see the end result. Some leaves in a row. Then I tried just to draw a few leaves on trees, but it was instantly apparent that the frame rates would turn into total dog poo-poo if I added any realistic amounts of leaves to actually cover the trees. I think it would be just too many polygons when you also consider that how many trees there can be in a scene. So I had to go with something cheaper. If you have watched my devlog number 1, you may recall the 3 different rendering techniques for grass that I mentioned. A simple terrain texture, grass cards and 3D geometries. The first, simply texturing the terrain, is computationally the cheapest option with no additional vertices needed to be drawn. Then the grass cards are the mid-ground, adding only 4 vertices for a card, although they do require somewhat costly transparency. And finally, just drawing the 3D geometry is computationally the most expensive option, but the modern graphics cards are powerful enough so that the amount of vertices is not that big of a deal anyway. Now this may seem obvious, but you cannot really have a grass texture that you turn into a grass card. Similarly, neither you can turn a simple texture or a grass card into a 3D geometry because you are one dimension too short on the data and the information just isn't there. But you can make textures and grass cards from the 3D geometry by rendering the 3D model into a texture by essentially snapping a photo of it. In fact, in some sense, this rendering to a texture is pretty much what video game engines do all the time, when they take a 3D scene and show it on your 2D screen. Actually, I have used render to texture already before for the water reflections on the devlog before this one. I generalized the code into a texturiser object that takes in a 3D model and sets render to texture, buffers, cameras and so on. After this, other game world objects can request this model's textured view by a name to loan it, and when all the loans have been returned, the texturiser cleans up the buffers, cameras and so on. Here you can see the initial textured leaves without transparency. It took quite some days of trial and error, but eventually I was able to produce beautiful leaves with great performance. Then I tested how the performance would do when increasing the amount of trees by tenfold. This did tank the frame rate, but not because the trees would be too expensive to draw, but because there were just too many separate objects to be drawn, causing a huge overhead. I think in future I'll combine the tree geometries into the terrain tiles, and after this I should be able to draw forests as thick as your mama. Nonetheless, I added Panda's level of detail system to the trees so that the faraway trees have less polygons on their trunks and less leaf guards on their branches. Then some smaller changes. So the grass how I made it in the Devlog number 1 has always the same green color and it stands out quite strongly from the terrain. To fix this, I first changed it so that the grass 3D model is actually created all white from the beginning. Then in Panda3D there is a neat feature to apply color scale transformation on a model similar to rotation or scale, for example. This color scaling multiplies the model's original color with the specified color. So for each grass tile I read the terrain color at its position and applied the color, and now the grass follows the color of the terrain. I also played with the idea of making grass something else than green, and maybe it would work for a fantasy game like OMAPELI, or what do you think? In future, however, I want to also adjust the density of the grass, as now it spawns even underwater. Some more minor changes were adjusting the camera behavior, as the old camera easily dived underground, adjusting the shadows to fill the world better and to avoid shadow waving effect when moving, and optimizations at few code hotpoints, especially in the grass tiling system. Perhaps I'll cover these topics in some of my future videos, but for now I think it's time to wrap up. Big thanks for watching this devlog, and I hope you have enjoyed. As usual, if you find anything worth commenting, please do, I'm waiting eager. As said in the beginning, you can also find me in the Birdie, where I mostly share short clips about the development. The next devlog will be either about OMAPELI's tiled terrain generation and how I have been trying to optimize it, or then alternatively about improving the grass view distance. I think these two are the last main things I will tackle with before really starting to work on the gameplay, but we'll see. Thanks for watching, and until next time, bye!